Hello friends, I welcome you all to this session on numerical methods using C++ programming. So in the previous lecture you have seen that how this Newton Raphson work. So once again I will revise with you that what the algorithm is, and then we will be writing the code. So first we will be having one function, then we will be writing another function for finding out the derivative, then we will be taking one guess value, and then based on that guess we will be evaluating the new value. So if the absolute difference between the new and the guess value happens to be less than some converging criteria, then our x new is the answer. If this condition doesn't satisfy us, then what we'll do is we will take the new value as the guess for the next iteration and again evaluate the new value for in the next iteration. And this thing will go on till we get some converged answer. So now let us head to this code block, and this was the code for the bisection method which we developed in the last class. The function was x square minus 5x plus 4. So let us run it once more. So this took 18 iterations to get the answer 4. So what we'll do is we will remove this internal part, okay, and then I'll make one more. So function we are already having, so this point is already done, then the derivative has to be written. So you already know how to write it. So double d dx, and then this will be accepting the function, so pointer, and then this is having one argument of double, and then this is differentiating with respect to x, and then let us take one more variable, that is h, which is the step size in differentiation. So let's take it as by default as 0.0001. Now inside what you will be doing, return, and here it is f x plus h minus f x minus h, and then this whole will be divided by 2 times h. That's it, your derivative is done. Now inside main you will be taking the guess value, and let us assign this guess as 0 for the time being. Let us say this is the 1. Now you will be writing your code. Now once this guess is done, then you have to move inside an iterative loop. So let us say while true, then what you have to do, you have to find out the new value. So double, or what you can do is you can also declare it here, double new, and then x new will be equal to x guess minus fx guess by derivative, that is d dx, for what, for this function, this one, and this is done with respect to x. We needn't have to pass h because h is already 0.0001, which is a very less value. Once this is done, then you evaluate the error and check for it. So if the absolute difference of new value and guess value is more, if this value, if this is less, then the answer has come. Otherwise you have to do the updation of guess. So if this value is more than, which we have already taken as 10 to the power minus 5, if this value is more than epsilon, then what you have to do is you have to say that the guess value now will be the new value. Otherwise, else, what you will say, else you will do what, see out the root is equal to xn, and then break from this particular loop. And I think you have done it. Yes, the program is over. It is so simple, friends, isn't it? You have taken one guess, you have evaluated new value, you have checked it with the guess value whether it is less than that epsilon or not. If it is coming out to be more, then update the guess. Otherwise you simply say this is the answer and then come out. So let us run it and see. So it is saying that x is not declared. I have written x. Yes, it has to be done with at x guess. Look here, this is with respect to x guess. Okay, now if you run it, you will be getting your answer. The root is 1. So This is with respect to the initial guess 0. And how many iteration it has taken? So let us do this also. Let us take count and assign this as 1. And once this is done, so what we'll be doing is we will be cout iteration is equal to count and then endl, and then we will be updating this count value. So if you run it now, so only in 4 iterations you got this answer 1. Now what will happen if I change the guess from 0 to, let's say, -2? Okay, so it took 5 iterations. If from -2 I move to -20, so it took only 7 iterations. So from -22, let's say it is 200, -200, only 10 iterations. And if I move to right, that is 5, I will be getting that 1. So another one, that is 4. So in only 4 iterations. So you see how fast this method of root evaluation is. That's why Newton Raphson is the first preference of majority of the people when it comes to root finding. So in this lecture, I have told you that how to write a code for finding out the root of any equation using Newton Raphson method. When I say any equation, means you can just change the function and that's it. So in this lecture, till this point only. In the next lecture, we'll learn some new topic. Thank you very much for watching it.